Hello everyone, welcome to 60 Thoughts. Today we are going to discuss one of the interesting topic. Verify the following two graphs G and G1 are isomorphic or not. Okay, now we verify the given graphs are isomorphic or not in G and G1. Okay, so what is given? These two graphs are given. So we have to verify these two graphs isomorphic or not by using isomorphism conditions. Okay, so before that we write a vertices of both graphs. Okay, so consider a vertex V1 in G is we have 5 vertices are there A, B, C, D, E, and the vertex V2 in G1 is V2 equal to P, Q, R, S, T. Okay. So what is step number 1? Step number 1, we have to verify both graphs having same number of vertices or not. Okay. Here you see in graph G having 5 vertices, in graph G2, G1 also having 5 vertices are there. Therefore, the total number of vertices in graph G and G1 are 5. What is step number 2? Step number 2, we have to verify equal number of edges in both graph G and G1 or not. Okay. In graph G having how many edges? 6 edges. 1, 2, 3, 4, 5, 6. Similarly, a graph G1 having 6 edges. 1, 2, 3, 4, 5, 6. Therefore, the total number of edges in both G and G1 are 6 vertices are there. Once it satisfies second step, go to third step. Otherwise, the given graphs are not isomorphism. Okay. What is step number 3? Step number 3, we have to verify the same vertices of degree in both G and G1 or not. Okay. So step number 3, to find degree of the vertices, both graph G and G1. How to find the degree of vertices? Number of edges connected to a particular vertex, that is called degree of the vertex. Okay. So now I am going to find it. What is degree of all vertices in G? What is degree of A? Here 2 edges connected. So therefore degree of A equal to 2. What is degree of B? A vertex B having 3 edges. Therefore degree of B is 3. Similarly, degree of C having 2 edges are there. So degree of C is 2. Degree of D 3. Degree of E 2. Similarly, we find the degree of all vertices in G1. What is degree of P? A vertex P having 3 edges. Therefore, degree of P is 3. What is degree of Q? A vertex Q having 2 edges. Therefore, degree of Q equal to 2. Similarly, we write degree of R is 3. Degree of S is 2. Degree of T is 2. Okay. Now you see here in graph G, 3 vertices having degree is 2. Okay. Corresponding to G1, here also 3 vertices having degree is 2. And similarly, in graph G, 2 vertex having degree 3. Here also 2 vertex having degree 3. Therefore, step number 3 is satisfied. What is step number 3? An equal number of vertices with a given degree. Okay, so this is called step number 3. In case any one of the vertices not satisfied this condition, therefore the given graphs are not isomorphism. Okay, but here it satisfied. Then we go to step number 4. What is step number 4 is we have to verify adjacency preserved, which means both graphs having edge preserving and vertices preserving. Okay. So now we consider a given graphs G and G1. Okay. So we have to verify all vertices in G and all vertices and G1 having one-to-one relation and on-to relations. Okay. If any one vertices does not satisfy, therefore the given graph is called what? Not isomorphic. Okay. So now I am going to choose one vertex here. Okay. That vertex is A. So choose a vertex. So before that we define a function f from G to G1. It satisfies edge preserving and vertices preserving. Okay. So I am going to choose one vertex. First vertex. So choose a vertex A. It has degree 2, which means how many edges are there? 2 edges are there. So it has degree 2. Okay. What are the adjacency vertices of A? There are 2 adjacent vertices. One is B, another one is E. Okay, another one is E. What is degree of B? The degree of B is 3. Okay. What is degree of E? The degree of E is 2. Okay. So see, coming to second graph, we have to choose one vertex. That vertex satisfies these conditions. Then these vertices are what? Edge preserving and vertices preserving of second graph. Okay. So coming to second graph, we have to choose one vertex, any one vertex. That vertex having first degree is 2. Okay. Here you see these three vertices having degree 2. Okay. You can choose any one vertex. Okay. So I am going to choose a vertex S. Okay. If we choose a vertex S, it has degree is 2. Okay. What are the adjacency vertices of S? There are two adjacency vertices. One is R, another one is 2. Sorry, P. What is degree of R? Degree of R is 3. What is degree of T? Degree of T is 2. Okay. So here you see this. Okay. So here we see these vertices are satisfied what all the conditions. Okay. So once it satisfies these conditions, therefore these are called what edge preserving and adjacency preserving, which means A is related to S. Every pre-image having a image. Okay. So now we suppose if we choose a vertex T, this one also what degree 2, it has two adjacency vertices, one is P, another one is Q, that is also satisfied. You can choose any one vertices based on the graph G output. Okay. So now we write a theory. So choose a vertex A in G, it has degree 2. Okay. And the two adjacency vertices of A are B and E, having degree sequence is what 3, 2. Similarly, we write a theory for a second graph. Choose a corresponding vertex S in G1. It has degree 2 and the two adjacency vertices of S are R and T having degree sequence 3, 2. Okay, it satisfies all the conditions. Therefore, A is relation to S and every pre-image having a image. So, we have to verify same concept each and okay. So, therefore, what? F of A equal to S. This is called what? Every pre-image having a image. So coming to one. So A is related to S. So remaining 4 vertices are there. We have to verify all 4 vertices satisfied here any one of the vertices. Okay. So now I am going to choose a vertex B. Okay. It has degree 3. Okay. What are the adjacency vertices of B? There are 3 adjacency vertices of B. One is A, another one is C, another one is D. Okay, 3 adjacency vertices of B. What is degree of A? Degree of A is 2. What is degree of C? Degree of C is also 2. What is degree of D? Degree of D also 3. Okay. So we have to choose one more vertex in G1. That vertex satisfies all these conditions. Then B is related to that particular vertex. How to choose? Here you see. If we choose one vertex, that vertex satisfied what? Degree is 3. In G1, these two vertex having degree 3. Okay. You can choose either this vertex or this vertex, and also it satisfies these 3 conditions. Okay. So now I am going to choose a vertex P. Okay. It has degree 3. Right. What are the adjacency vertices of P? There are 3 adjacent vertices. One is R, another one is Q, another one is T. Okay. What is degree of R? Degree of R is 3. Okay. What is degree of Q? Degree of Q is 2. What is degree of T? Degree of T also 2. Here you see all the conditions satisfied. Therefore, B is relation to P. Okay. So now we write a theory. Choose a vertex B in graph G. It has degree 3 and the 3 adjacent vertices of B are A, C, D having degree sequence 2, 2, 3. Similarly, we choose a corresponding vertex P in graph G1. It has degree 3. There are 3 adjacent vertices of P, that is R, Q and T having degree sequence 3, 2, 2. Therefore, F of B is what? Equal to P. Every image having a image, every image having image. Therefore, this is called adjacency preserved. Okay, therefore what? B is related to what? P. Next, we have remaining three vertices are there. We have to verify these three vertices satisfied or not. If any one vertices does not satisfy, therefore the given graph is called what? Not isomorphic. Okay. So now I am going to choose a third vertex C. So choose a vertex C. It has a degree 2. Okay. What are the adjacency vertices of C? Only two. One is what? B. Another one is D. What is degree of B? 3. What is degree of D? That is also 3. Okay. So we have to choose one more vertex in G1, either R, Q, T. That vertex satisfied these three conditions. Okay. So here you see how many vertices having degree 2, only 2, these two vertex. Okay. If we choose these two vertex, and also it satisfies these three conditions. Okay. If we choose a vertex T, degree 2, there are two adjacent vertices. One is P, another one is S. But here you see degree 3, here degree 2. So that I am not choosing the vertex T. If you choose a vertex Q, it has degree 2. Okay. There are two adjacent vertices of Q, that is P, another one is R. Okay. What is degree of P? That is degree is 3. What is degree of R? That is also 3. Here you see all the conditions satisfied. Therefore, C is relation to Q. Every pre-image having a image. So this is called adjacency preserved. So now we write a theory. Choose a vertex C in G. It has degree 2 and two adjacent vertices of C, that is B and D, having degree sequence 3, 3. Similarly, we choose corresponding vertex Q. It has degree 2. There are two adjacent vertices of Q. One is P, another one is R, having degree sequence 3, 3. Therefore, f of C equal to what? Q. Okay, this is called a pre-image adjacency preserved. Okay, therefore what? C is related to Q. Remaining two vertices are there. We have to verify this. The star போட்டுருக்கோம் இல்லையா அதெல்லாம் வந்து மேப்பிங் ஆயிடுச்சு. Next, we choose a vertex D in graph G. It has a degree sequence is 3. What are the adjacency vertices of D? There are 3. One is C, another one is B, another one is E. Okay. What is degree sequence of B? 3. What is degree sequence of C? That is also degree is 2. What is degree sequence of E? That is 2. Okay. So we have to choose one vertex, either R and R or T. That vertex satisfied these conditions. Okay. So now I am going to choose the vertex R. Why? This vertex only having degree 3. This vertex having degree 2. So that choose a vertex R in graph G1. It has degree 3. And there are 3 adjacent vertices of R. What are the 3? One is P, another one is Q, another one is S. Okay. Having the degree sequence. P is degree 3, Q is degree 2, S is degree 2. Okay. So therefore what? D is relation to R, which means vertices preserving and edge preserving. Therefore adjacency preserved satisfied. So now we write a theory. Choose a vertex in G. It has a degree 3. There are 3 vertices of D. One is B, another one is C, another one is D. Having degree sequence 3, 2. Similarly, choose a vertex R in graph G1. It has a degree. There are 3 adjacent vertices of R. One is P, another one is S. Having sequence 3, 2, 2. Therefore, f of D equal to R. Okay. So therefore, D is related to R. Okay. Only one vertex is bending. That is E in graph G. Another vertex is what? T in graph G1. So now we choose a graph E. It has degree 2. Right? What are the adjacency vertices of E? Only 2 adjacent vertices. One is A. Another one is D. Okay. What is degree of A? 2. What is degree of D? 3. Okay. Same thing, same condition is satisfied in G1. Choose a last vertex T. It has a degree 2. Okay, there are two adjacent vertices of T. One is P, another one is S. Okay, having degree sequence 3, another one is degree sequence is 2. Okay, therefore what adjacency preserved, which means vertices preserving and the edge preserving. Now we write a theory. Choose a vertex E in G. It has degree 2. There are two adjacency vertices of E. One is E A, another one is D, having degree sequence 2 comma 3. Similarly, we choose a vertex T in graph G1. It has degree 2. There are two adjacency vertices of T are P and S, having degree sequence 3 comma 2. Therefore, f of E equal to what? T. So here you see all vertices satisfied what? Adjacency preserved, and also all four conditions satisfied. Okay, therefore these two graphs are called isomorphic graph. I hope you are enjoying this session. Thank you.